Okay, so this is the lesson on common factors and multiples. This is the tutorial for that. Make sure that you are going to the Google Classroom to get your guided notes. Those are found in the section that states guided notes, and that should be of the same title, common factors and multiples. And so the objective in this lesson is that we're going to express a sum of two whole numbers with a common factor as a multiple of a sum of two whole numbers with no common factor.
Introduction. Harold and 5 of his friends are playing jacks. Each of them has his own set of balls and jacks. But after playing for a while, they realize that their balls and jacks are all mixed up. They have 24 balls and 60 jacks in all. Because they each have a set with the same number of jacks and balls, they can split the 24 balls and 60 jacks evenly among themselves. In this lesson, you'll see how to solve this problem for Harold and his friends mathematically by using the distributive property. You'll also study greatest common factors, GCF, and least common multiples, LCM. Least common multiples and greatest common factors. Imagine you're making one sandwich for yourself and 2 more sandwiches for your brothers. To make each sandwich, you need 2 slices of bread, 1 slice of cheese, and 4 slices of tomato. How can you determine how much of each ingredient you need to make all 3 sandwiches? The distributive property. The ingredients that you need for one sandwich can be written as the expression 2 plus 1 plus 4. So to make 3 sandwiches, you need 3 times the sum of 2 plus 1 plus 4. Now multiply 3 by each number inside the parentheses. Equals 3 times 2 plus 3 times 1 plus 3 times 4 equals 6 plus 3 plus 12. You just use the distributive property. To make 3 sandwiches, you need 3 times 2 equals 6 slices of bread, 3 times 1 equals 3 slices of cheese, and 3 times 4 equals 12 slices of tomato. Now you know the ingredients needed for 3 sandwiches: 6 slices of bread, 3 slices of cheese, and 12 slices of tomato. The distributive property you use can be written in the form of 2 general equations. Y times the sum of A plus B equals Y times A plus Y times B, and Y times the difference of A minus B equals Y times A minus Y times B. If you multiply the sum or the difference of 2 or more values by a common number, you get the same result as when you multiply each value within the parentheses separately. The distributive property can be used to simplify mathematical expressions. Let's use the expression 32 plus 56 as an example. If a number exactly divides both numbers in the expression, you can pull that number out of the parentheses. For example, 32 plus 56 equals 16 times 2 plus 28 times 2 equals 2 times the sum of 16 plus 28. In the equation above, 2 is a factor of 32 and 56. Similarly, 4 is a factor of both 32 and 56. So we can simplify the expression further as 32 plus 56 equals 4 times 8 plus 4 times 14 equals 4 times the sum of 8 plus 14. Again, the number 2 is a common factor of 8 and 14. So the expression can be simplified further. 4 times the sum of 8 plus 14 equals 4 times 2 times the sum of 4 plus 7 equals 8 times the sum of 4 plus 7. Greatest common factor. You can apply the distributive property to the sum of a group of numbers only if there is at least one whole number other than 1 that divides all the numbers in the sum evenly. Such a number is called a common factor. For example, the sum 18 plus 19 cannot be simplified by applying the distributive property because 18 and 19 do not have a common factor other than 1. 18 plus 19 equals 1 times the sum of 18 plus 19. On the other hand, as you saw in the previous example, the numbers in the expression 32 plus 56 have 3 common factors, 2, 4, and 8. The largest number that evenly divides each number in a set is called the greatest common factor, GCF, of that set of numbers. Referring to the previous example, we can say that the GCF of 32 and 56 is 8. Observe that after pulling out the greatest common factor, 8, the numbers left inside the parentheses, 4 and 7, have no common factor. Let's look at some examples of finding the GCF, beginning with the GCF of the expression 20 plus 16. The numbers 20 and 16 are both divisible by 2. 20 plus 16 equals 2 times the sum of 10 plus 8. Although 2 is a factor of 20 and 16, the numbers in the expression 10 plus 8 still have a common factor. So 2 is not the GCF of 20 and 16. Again, 2 is a common factor of 10 and 8. Pulling 2 out of the parentheses, we get 2 times the sum of 10 plus 8 equals 2 times 2 times the sum of 5 plus 4 equals 4 times the sum of 5 plus 4. At this stage, the remaining numbers 5 and 4 do not have a common factor, so 4 is the GCF of the expression 20 plus 16. In the same way, we can find the GCF of expressions with more than 2 numbers. Let's find the GCF of 12 plus 24 plus 18. We can start by pulling the common factor 3 out of the sum 12 plus 24 plus 18 equals 3 times the sum of 4 plus 8 plus 6. The numbers inside the parentheses still have a common factor, 2. If we take 2 out of the parentheses, we get 3 times the sum of 4 plus 8 plus 6 equals 3 times 2 times the sum of 2 plus 4 plus 3 equals 6 times the sum of 2 plus 4 plus 3. The GCF of 12 plus 24 plus 18 is 6.
Okay, so all of that explained the greatest common factor, but there is maybe a little bit simpler way to understand greatest common factor. So we're still going to be using that distributive factor or distributive property that we saw, but one of the things that we can do instead of continuing to divide out, is to find the GCF using a T-chart, okay? So again, the greatest common factor okay. The greatest common factor is the largest number that is a factor of 2 or more numbers. So if we look at finding the GCF of 12 and 21, we can look at the factors of 12 first. And I'm going to make a T-chart that shows all of the factors of 12. So I know that 1 times 12 is what I'm going to start with, and then I want to look at the number 2. Does 2 go into 12? Yes, 2 times 6 is 12. So 2 and 6 are a factor of 12. How about the number 3? 3 does go into 12, and it goes in 4 times. And then the number 4 goes in 3 times. Once we start repeating factors, then we know that we're done. Okay, so we have all of those factors listed at least once, and we actually don't need to write this down because it's repeating. So as long as we go in order, we'll get all of those factors. So let's look at the factors of 21. and we do a t-chart. 1 times 21 is what we want to start with. 2 won't go into 21 because 21 is not even. 3 goes into 21 7 times. 3 times 7 is 21. 4 will not go into 21 because 4 goes into 20, and then there's not enough. 5 won't go into 21. 6 will not go into 21, and 7 goes in 3 times, and we've started to repeat the factors. Once we repeat, we know we have them all. So these are all of the factors of 21. And then what we want to do is look in both lists and see the largest number that's in both lists. And so the common factor, the greatest common factor of 12 and 21 is 3. Now, if I wanted to use the distributive property to find out the greatest common factor, I can say that 3 is going to come out, and then what's left, 3 times 4 is 12, and 3 times 7 is 21. So using the distributive property to find the sum of these two, this would be the expression that's left.